various competitive examinations, you should be able to solve the problems in lesser time. I will explain how to do a sum in lesser time. Here there is a sum where three equal resistances of 15 ohm are connected across a potential difference of 5 volt. You have to find the current passing through the circuit, current drawn from the battery. It is based on Ohm's law. V is equal to IR. Then you can get the current is equal to voltage divided by resistance. When resistances are connected in parallel, effective resistance is given by this relation. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by Rp is equal to 1 by 15 plus 1 by 15 plus 1 by 15. So when you add this, 3 divided by 15, 15 common denominator, then 1 plus 2 plus 1 plus, that is 3. So 1 by Rp is 3 by 15. So Rp is 15 by 3. So effective resistance is 5 ohm. Now current is equal to voltage divided by resistance. Voltage is 5. Then effective resistance is 5. 5 divided by 5 is 1 ampere. But in this case, this much calculation not needed. 3 equal resistances are connected. 15, 15, again 15. So 3 equal resistances are connected. Then effective resistance will be 15 divided by 3. So effective resistance 5. Then net voltage is 5. Potential difference is 5, so 5 divided by 5, 1 ampere. Without any calculation, you can say the current is 1 ampere. The main current, the current drawn from the battery is 1 ampere. Then here there are 3 ways for the current. So here current will be 1 by 3. Here equally it will be divided. So current through each branch will be 1/3 of the main current. The main current is 1 ampere. In this sum, 3 resistances are connected in series to a potential difference of 9 volt. Then one resistance is unknown. It is P. You have to find the value of P. This is 3 ohm. This is 2.5. The question is given, current is 1 ampere. Then as per Ohm's law, V is equal to IR, so I is equal to V by R. Then since resistances are connected in series, total resistance is the sum of the individual resistances. So 3 plus 2.5 plus P. So 3 plus 2.5, 5.5 plus P. So this is the total resistance in the circuit. Then current is given to be 1 ampere, so we can substitute 1 for this I. Then potential difference is given to be 9 volt. Then resistance 5.5 plus P. So after rearranging, you can write like this. 9 is equal to 1 into 5.5 plus P. So you can write like this. So P is equal to 9 minus 5.5. So the answer is 3.5 ohm. Then this problem you can do it in a lesser time. Current is given to be 1 ampere. In this case, if current is 1 ampere, easily you can arrive at the answer. Add these two and subtract from this 9. So that is possible only if the current is 1 ampere. You can do it in a lesser time by using this technique. 3 plus 2.5, that is 5.5, from that you subtract it from 9. So 9 minus 5.5 is 3.5 ohm. In this problem, temperature coefficient of resistance of a wire is given to be 0.00125 per degree Celsius. It is represented by alpha. At 300 Kelvin, resistance of the wire is 1 ohm. You have to find out the temperature at which it will become 2 ohm. This is a relation giving the resistance of the wire and temperature. Resistance of a wire depends on the temperature. RT, resistance at T degree Celsius, equal to resistance at 0 Kelvin into 1 plus alpha T. Here temperature is given in Kelvin, but temperature coefficient of resistance is given per degree Celsius. So this is to be converted into Celsius. So subtract 273, then Kelvin will become Celsius. So 27 degree Celsius. Now when 300 Kelvin, resistance is 1 ohm, then is equal to R0 1 plus alpha. For this T we have to substitute in Celsius because this is given in per degree Celsius. If you substitute in Kelvin, that means 300 in this expression, you will arrive at 1400 Kelvin. That's a wrong answer. So in multiple choice questions that also will be given. So if you put to 300 and do the calculation, you will arrive at the wrong answer. So be careful to substitute in Celsius. Now when resistance is 2 ohm, we have to get the temperature. Now you write two equations. Then for getting the temperature, you divide this equation by this equation. Now R0 will get cancelled. So 2 by 1 is equal to 2. Then R0 will get cancelled. So 1 plus alpha T divided by 1 plus 27 alpha. When you divide this equation by this equation, you will arrive at this equation. Now from this we can write like this: 1 plus alpha T is equal to 2 into 1 plus 27 alpha. So you remove this bracket. So 2 into 1, 2 plus 54 alpha. Now take this 1 to the other side. So 2 minus 1 is 1 plus 54 into alpha. Alpha is given 0.00125. So when you multiply and add, you will arrive at this number. So T is equal to 1.0675 divided by alpha. Substitute the value of alpha. So you will arrive at this answer. That is, answer you are getting in Celsius. If you want to get it in Kelvin, so add 273. The correct answer is 1127 Kelvin. If you do this calculation by putting 300, you will arrive at 1400 Kelvin. But since it is the temperature coefficient of resistance is given in per degree Celsius, you have to substitute in Celsius in this relation. A cell of EMF 2.1 volt is connected across a resistance of 10 ohm. The current in the circuit is 0.2 ampere. We have to find the internal resistance of the cell. Internal resistance of the cell is represented by small r, external resistance by capital R. Then EMF of the cell is represented by psi, Greek letter. Then this is the relation for internal resistance of the cell. Internal resistance R is equal to modulus of psi minus V by V into R, where psi is the EMF of the cell, V is the potential difference across this resistance when the cell is sending current. Now the current is 0.2 ampere, resistance is 10. So using Ohm's law, we can get the potential difference across this resistance. Potential difference is current into resistance. Current is 0.2, resistance is 10. So potential difference across this resistance is 2 volt. EMF of the cell is 2.1. So we can substitute EMF of the cell 2.1 minus potential difference across this resistance is 2, then divided by V. So we can substitute 2. Then 2.1 minus 2 is 0.1 by 2 when you take the modulus, 0.1 by 2 into 10. 0.1 into 10 is 1, then that is to be divided by 2. So 1 by 2, that is 0.5 ohm. The internal resistance of this cell is 0.5 ohm.